Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the most mysterious companions of our lives, time. It's with you every second, though you rarely notice it. You measure your days by it, you remember your past because of it, and you imagine your future along its path. Yet when you pause and ask yourself, what is time, really? The answer slips away like mist between your fingers. It is this gentle mystery we'll be exploring together, slowly and without hurry. Think of all the little ways time brushes against your day. The whistle of a kettle that seems to take forever when you're waiting, but hardly a breath when you're distracted. The long elastic hours of childhood summers that seemed endless, compared with the fleeting weeks of adulthood, where seasons come and go almost without warning. The clock on the wall ticks steadily, indifferent to your feelings, and yet your perception bends and twists those ticks into different shapes. You live in that tension between time as physics and time as experience, and both feel true. Philosophers have wrestled with this duality for millennia. St. Augustine, writing in the 4th century, admitted with striking honesty, "What is time? If no one asks me, I know. If I wish to explain, I do not." His words still echo today, reminding us that time is both obvious and elusive, a reality you live with yet cannot fully describe. Is time something woven into the fabric of the universe, flowing like a river no matter what you think of it? Or is it a pattern your mind constructs, a perception shaped by biology, memory and attention? Imagine for a moment that you are lying comfortably in your bed, listening to the faint hum of a fan. Outside your window, the night has settled in, and the world moves on with its quiet rhythm. Somewhere, thousands of kilometers away, dawn is just beginning, pouring light into a kitchen where someone is stirring coffee. At the same instant, a spacecraft circles Earth, experiencing time at a slightly different rate than you are, thanks to the subtleties of relativity. The present moment, this shared now, is both yours, alone, and stretched across countless experiences, each one shaped differently by perspective and physics. That is the puzzle. Time feels deeply personal, yet it is also a universal ingredient in the recipe of reality. If you tried to remove it from your life, nothing would remain coherent. A song would collapse into a meaningless jumble of notes. A story would lose its beginning, middle, and end. Your very sense of identity, your memory of who you were yesterday and who you hope to be tomorrow would unravel. Without time, there is no continuity, no narrative, only scattered fragments. And yet, if you ask a physicist at the smallest scales of quantum mechanics, they might whisper that time is not fundamental at all. It may be an emergent property, like the warmth of a fire that comes not from a single flame, but from the collective motion of countless particles. But let's not race too far ahead just yet. Tonight's journey is not a sprint through equations and paradoxes, but a slow walk along the shore of this mystery. We'll begin with the history of how humans have tried to measure and tame time, from sundials that followed shadows across stone, to pendulums swinging in medieval towers, to the atomic clocks beating with such precision that they guide satellites above your head. We'll drift from there into the realms of physics, where Newton imagined time as an absolute backdrop, steady and unchanging, and where Einstein later bent that backdrop into the pliable fabric of spacetime. We'll wander through biology, tracing the quiet tick of your circadian rhythms and the steady drumming of your heart. And we'll step softly into the landscapes of psychology, where memory stretches and compresses time, where boredom drags it out, and where dreams compress it into surreal stories that play out in seconds. Each part of the journey is like a lantern, casting light on one side of the mystery. None will banish the shadows entirely, but together they may give you a deeper, calmer appreciation of the strange thing we call time. You might find yourself marvelling at how entropy gives time its one-way arrow, or smiling at the thought that your head ages a fraction of a second faster than your feet, simply because of gravity's subtle tug. You may feel reassured that even if time is an illusion, it is a necessary one and a beautiful one. For now, though, let yourself settle into the pace of this exploration. There is no rush, no deadline. Time is not a taskmaster here. If your mind drifts or your eyelids grow heavy, that is perfectly fine. We're not here to conquer time or to solve it like a puzzle. We're here to sit with it, like you might sit with a quiet friend on a long evening, letting the conversation meander without urgency. And perhaps, as you listen, you will notice the gentle ways your own body keeps time, the rhythm of your breath, rising and falling like a tide, the steady beat of your heart, soft as a drum heard through walls, the way your thoughts arrive and fade one after another like waves lapping a shoreline. These are your personal clocks woven into your being, reminding you that time is not just out there in the stars, but also in here, in the quiet chambers of your body and mind. So let us begin this journey together. We'll start not with equations, but with stories. The stories of how humans first noticed time, measured it, and tried to capture its rhythm. Imagine a sundial in an ancient courtyard, a shadow slowly moving across carved stone as a child watches with curiosity. That shadow, that slow dance of light, is one of the earliest sparks in humanity's long relationship with time. From that spark, civilizations rose, sciences unfolded, and clocks began to tick. And from that spark, tonight's gentle exploration begins. If you step back through the centuries, long before the glow of digital screens and the tick of pendulum clocks, you would find that the first humans to wonder about time did not think of hours and minutes at all. They thought of the sun. It was the most faithful companion in the sky, rising each morning, climbing steadily overhead, and sinking away into night. That steady cycle, light into darkness and back again, was the earliest rhythm by which people ordered their lives. Day meant work and movement. Night meant stillness and rest. In this way, the sky itself was humanity's first clock. Imagine a small village thousands of years ago. No bells to mark the hours, no alarms to rattle you awake. Instead, the day begins when the first shafts of light spill over the horizon, painting fields and rooftops in pale gold. A shepherd leads animals out once the shadows are long, a farmer bends to sow seeds when the sun reaches a certain height, and a child learns that evening is near when the sun's glow is red on the walls of the home. No one needed to ask what time it was. The answer was written across the heavens in light and shadow. As human life grew more complex, so did the need to measure those cycles more precisely. It is one thing to know that the sun will rise, and another to know how long until midday, or how much daylight remains for travel. And so the sundial was born, a simple yet profound invention. Place a stick, a gnomon, upright in the ground, and it will cast a shadow. As the sun moves across the sky, that shadow shifts. With markings carefully placed on the ground or carved into stone, the passing of hours becomes visible. The sun's movement was transformed into a language of lines, and for the first time, time itself could be pointed to, read and shared. There is a kind of poetry in sundials. They do not tick or chime, they whisper. Their hands are shadows that slide almost imperceptibly, teaching patience to those who watch. The sundial does not argue with the weather. If the clouds cover the sky, the clock disappears and you must wait. In that way, it reminds us that timekeeping once belonged not to human machines, but to nature itself, tied to the flow of the cosmos. Of course, sundials were not the only early attempts. In Egypt and Babylon, water clocks, called clepsydrae, became common. A vessel with a small hole in the bottom allowed water to drip at a steady rate, and as it fell, the level in the vessel changed, marking the passage of time. Where sundials depended on sunlight, water clocks could be used indoors or at night when the stars glittered overhead. It was a kind of captured river, flowing not across land but through a clay pot, giving people their first sense of time flowing in measured drops. Other cultures found rhythms in the sky itself. The phases of the moon became a calendar, waxing and waning like a celestial breath. Farmers planted crops by lunar cycles. Festivals were timed to harvest moons or solstices. The Mayans constructed elaborate calendars that tracked celestial patterns with astonishing accuracy, while ancient Chinese astronomers studied the heavens to refine calendars that governed both agriculture and governance. Each system was different, yet all pointed to the same truth. Humans were compelled to measure, to count, to find their place in the rhythm of the universe. If you close your eyes for a moment, you can picture an ancient courtyard where a sundial stands. The stone is warm beneath the sun, and people glance at it as they pass, noting how far the shadow has crept. Somewhere else, in a dim room, water drips in steady intervals, each drop a reminder that moments are slipping away. These are not clocks as we know them today, yet they were powerful enough to shape lives. Markets opened when shadows reached a certain mark. Judges limited speeches by the draining of a water clock. Soldiers marched by lunar cycles, trusting the heavens more than any human command. What these early inventions reveal is not just a desire to know the time, but a desire to agree on time. Shared measurement allowed coordination. Without it, one farmer might show up at dawn, another at midday, and both would argue over whose sense of morning was correct. A sundial carved in stone or a water clock dripping in public view created a common reference. Time was no longer entirely subjective, it was social. And with that, a new kind of order emerged. Yet even then, these systems carried an important reminder. Time was still tied to the natural world. Sundials leaned on the sun. Water clocks relied on the flow of liquid. Lunar calendars rose and fell with the phases of the moon. Time was measured, but it was not yet separated from the living cosmos. To know the hour was also to know the sky, the seasons, the water, the world itself. It's worth pausing to consider how different that feels from our own relationship with time. Today you may glance at your phone and see a glowing number, precise to the second. It feels detached, clinical, indifferent. But to those early observers, each passing hour was embodied in the sky and the earth, part of the living environment. Time was not just counted, it was experienced. The sweep of a shadow, the drip of water, the swelling of a moon. These were reminders that life was not separate from nature's rhythm, but woven into it. As you drift further into tonight's journey, let that thought linger. Imagine yourself beside that ancient sundial, the air warm, the sky slowly shifting, shadows creeping as the hours unfold. There is no rush, no deadline, only the slow movement of light, marking time not in seconds or minutes, but in a quiet cosmic cadence. And perhaps, as the shadow lengthens, you notice the same truth people saw thousands of years ago. Time is not something you own or control. It is something you share with the world around you. The sundial and the water clock carried humanity a long way, but they had limits. Sundials vanish in cloudy weather or at night, and water clocks can freeze in winter or drip unevenly if the hole wears wider with time. As society grew more intricate, as cities swelled and voyages stretched farther across oceans, the need for greater precision became undeniable. Farmers could live by shadows, but merchants and sailors needed something steadier, more exact and more portable. Time, in a sense, had to be tamed. The first mechanical clocks built in medieval Europe were less like the sleek wristwatches you know today, and more like towers of iron and wood. They did not sit quietly on a table. They loomed above villages, fixed into church steeples or public squares, their gears clanking like metallic hearts. These clocks did not tell time by minutes at first, but by striking bells at regular intervals. The sound carried across towns, calling monks to prayer, merchants to markets, and citizens to daily rhythms. It was not yet personal time, it was communal, a voice from above reminding everyone that the day was unfolding in measured steps. At the heart of these early machines was a clever innovation, the escapement. Imagine a set of gears wanting to spin freely under the pull of a heavy weight. Left alone, they would whirl out of control. The escapement interrupts that free fall, allowing the gears to move forward in steady increments. Each tick is a captured moment, each tock a measured release. For the first time, time was not flowing in shadows or dripping in drops of water. It was being chopped into equal beats by human-made teeth of brass and steel. Then came one of the most elegant solutions ever devised for measuring time, the pendulum. In the 17th century, Galileo noticed that a swinging lamp in a cathedral took nearly the same time to swing back and forth, no matter how wide the arc. Later, Christian Huygens transformed that observation into invention, building the first pendulum clock. The long arm, swinging with hypnotic rhythm, became a physical embodiment of steadiness. Each swing marked a precise beat, so reliable that errors shrank from hours to mere seconds per day. For a world still ruled by the rising sun and fading moon, this was a revolution. Picture a family gathering in a modest home of the 18th century. Against the wall stands a tall case clock, what we often call a grandfather clock, its pendulum swaying inside a wooden cabinet. Each swing is a soft heartbeat, steady, patient, never hurried. The family eats supper to its rhythm, children fall asleep to its muffled tick, and the parents know when Sunday service begins by glancing at its face. Time, once a cosmic phenomenon painted across the sky, now swings gently in the corner of the living room. But pendulums, for all their elegance, could not solve one of the greatest challenges of the age: navigation. As seafaring nations expanded across the oceans, sailors faced a puzzle known as the longitude. Problem latitude could be found by the height of the sun or stars, but longitude, how far east or west a ship had travelled, was far trickier. Without it, ships became lost, wrecks multiplied, and voyages turned perilous. To solve it, mariners needed a clock that could keep time precisely on a ship tossed by waves, battered by storms, far from land for months at a stretch. Pendulums were too delicate, their swings disrupted by the rocking of the sea. Something new was needed. Enter John Harrison, an English carpenter with little formal training but extraordinary persistence. In the 18th century, he devoted decades to solving the longitude problem. His answer was the marine chronometer, a compact and resilient timekeeper built not on pendulums, but on balance wheels and intricate mechanisms resistant to humidity, temperature, and motion. The chronometer did more than tick reliably. It transformed the world. By keeping Greenwich time aboard a ship, navigators could compare local noon, the moment the sun reached its peak overhead, with the clock's reading. The difference revealed longitude, and with it, the ship's true place on the globe. Suddenly, oceans that once seemed infinite became mapped in hours and minutes. Think of the weight of that achievement. With each reliable tick, ships carried goods, knowledge, and people across the seas with confidence. Empires grew, trade expanded, and cultures intertwined, all because someone could now carry the certainty of time across rolling waves. The chronometer was more than a tool. It was a compass of hours, a guardian of safe passage, a quiet hero in the age of exploration. From village bells to pendulums to chronometers, each leap forward in timekeeping changed not only how precisely we measured time, but how we lived it. The communal rhythm of bells became the private tick of home clocks, the elegant swing of pendulums became the heartbeat of domestic life, and the resilient tick of marine chronometers stretched human reach across oceans, shrinking the planet by synchronizing distant shores. Time, once intangible, now lived in gears, weights, and springs. And yet, beneath all this mechanical ingenuity, the same paradox lingered. Were these clocks revealing something real about time, or were they merely enforcing a rhythm upon us? Was the universe itself ticking, or were humans carving ticks into an otherwise continuous flow? The clocks did not answer the question, but they gave it form. They turned time from a feeling into a measurement, from a mystery into a tool, and in doing so, they prepared the stage for even greater revolutions to come. Tonight, as you picture those ancient pendulums swinging in candlelit rooms, or sailors gazing at a chronometer under starlit skies, let the thoughts settle gently in your mind. Each tick and swing is not just a mark of passing time, but a story of how humanity has tried to grasp the ungraspable. From shadows to gears, from drips to springs, we are always reaching toward the same horizon. And perhaps, like those sailors guided by invisible lines across an endless sea, you too are guided tonight, not to an answer, but to a deeper appreciation of the mystery of time. By the time the 19th century gave way to the 20th, the pendulum clock had become a symbol of elegance and domestic order, its slow swing a reassurance that life could be measured with a steady hand. Marine chronometers had carried explorers across uncharted seas, stitching the globe together with threads of reliable time. But as industries rose, railroads expanded, and telegraph wires stitched continents together, the hunger for still greater precision grew louder. A pendulum might keep excellent time in a quiet study, but in the clang and roar of modern life, seconds mattered. Trains had to leave stations on schedule, stock exchanges thrived on precise timing, and the growing world of science demanded measurements more delicate than any swinging arm of brass could deliver. It was in this age of change that quartz crystals entered the scene. At first glance, quartz seems unremarkable, a clear mineral, often cloudy or tinged with faint colours, found in mountains and riverbeds. Yet hidden inside its crystalline structure is a remarkable property. When a small electric charge passes through a piece of quartz, the crystal vibrates at a precise frequency. And unlike pendulums that slow in damp air or springs that tighten and loosen with temperature, quartz oscillates with astonishing steadiness. Each vibration is like a whisper from nature itself, consistent and unwavering, a rhythm waiting to be counted. The quartz clock transformed timekeeping in the 20th century. No longer did households depend on winding pendulums, no longer did laboratories endure the drift of mechanical gears. Instead, a crystal smaller than a fingernail provided accuracy that pendulums could only dream of. By the 1930s, quartz clocks were keeping time to within a fraction of a second per day, and by mid-century they had found their way into watches, radios, and later, the first digital devices. Picture yourself in the 1970s, slipping a slim quartz watch onto your wrist. It ticks not with a swinging pendulum, but with invisible vibrations humming deep inside. You do not see the crystal, yet you trust its pulse more than you might trust your own heartbeat. It connects you to schedules, to meetings, to departures and arrivals. The small, constant song of quartz became a new heartbeat for civilization, one that never wavered, never tired. But even quartz, with all its precision, was not enough for the growing demands of the 20th century. The world was shrinking under the cables of telegraphs, the rails of trains, and eventually the radio waves of satellites. As scientists probed deeper into the structure of matter, they began to look not at crystals, but at the very atoms themselves. If quartz could sing with regularity, then atoms, those fundamental building blocks of the universe, might sing with a perfection even greater. Enter the atomic clock. Built in the mid-20th century, it did not measure time by gears or crystals, but by the vibrations of atoms, most often cesium. Atoms, when exposed to specific electromagnetic energy, absorb and release it in regular, predictable oscillations. These oscillations happen at frequencies unimaginably high, billions of times per second, and they are so consistent that they became the new definition of time itself. In 1967, scientists agreed to define the second not by the Earth's rotation, which wobbles and drifts, but by the vibrations of cesium-133 atoms, precisely 9,192,631,770 cycles per second. Humanity had tied its most fundamental measure not to the sky above, nor to the crystals beneath our feet, but to the invisible, unchanging rhythms of the atoms themselves. Imagine a laboratory where an atomic clock sits humming quietly, its presence almost unnoticeable, yet its authority absolute. No swinging pendulums, no dripping water, no moving shadows, only the silent certainty of atoms counting their cycles with flawless precision. From this hum of cesium or rubidium, every clock on Earth can be synchronized. Your phone, your computer, the satellites circling the planet, all keep their promises because somewhere, atoms are whispering the true beat of time. The importance of such precision extends far beyond laboratories. When you open a map app and see your location pinned to within a few meters, you are benefiting from atomic time. GPS satellites orbit Earth with clocks on board, and those clocks tick slightly differently than they would on the ground, because gravity and velocity shift the flow of time ever so subtly. Without accounting for Einstein's relativity, without the anchoring hand of atomic clocks, GPS would drift by kilometers each day. Planes would miss their paths, ships would veer off course, and even the simple act of navigating to a cafe would become unreliable. Finance too depends on these clocks. When millions of trades flash across stock exchanges in microseconds, precise timestamps prevent chaos. Telecommunications, power grids, the coordination of scientific experiments across continents, all rely on the unyielding steadiness of atomic hearts. The pulse of atoms has become the pulse of civilization. And yet, as much as these clocks bind us to the world with order and precision, they also remind us of something humbling. No matter how fine our instruments, no matter how many decimal places we carve into the second, our human experience of time is never so exact. You can sit waiting for a kettle to boil and feel each moment drag endlessly. You can fall into a conversation or a walk at dusk and lose track of an entire hour. The quartz and atomic clocks may whisper the truth of the universe's rhythm, but your heart and your memory tell a different story, one of time stretched and folded by feeling. Perhaps that is why, even as satellites beam atomic precision down upon us, we still keep pendulum clocks on our mantles and wear wristwatches that tick with gears. They are not as accurate, but they carry a kind of warmth, a reminder that time is not only a number but also a companion. The quartz hum and the atomic beat may define the second, but the pendulum's swing and the sundial's shadow remind us that time is also lived. So tonight, as you drift further into this exploration, you might picture all these clocks together. A sundial casting its slow shadow, a pendulum swaying in an oak cabinet, a quartz watch humming invisibly, and a cesium atom vibrating in a laboratory. They are all telling the same story in different languages, each pointing toward the same mystery. And you, lying here in the quiet, are part of that story too. Your breath rises and falls, your heart ticks softly beneath your ribs, and time moves forward, whether you measure it or not. For centuries after sundials and pendulums had taught people to measure the passing of hours, another question lingered. What exactly is this thing we are measuring? When the shadow on a stone shifts or the pendulum swings, are we recording something real flowing through the universe, or are we simply marking change itself? In the 17th century, a man sitting beneath an apple tree, at least in legend, gave the world one of its most influential answers. That man was Isaac Newton. Newton is often remembered for apples, for gravity, for the way he reshaped our understanding of the cosmos. Yet tucked inside his monumental work Philosophia Naturalis Principia Mathematica was a profound statement about time. To Newton, time was not a trick of perception, not a flow shaped by memory or biology. It was absolute, universal, and steady. Imagine a great stage stretching endlessly in every direction. Upon this stage, the actors, planets, stars, people, and apples move and interact. But the stage itself does not wobble or bend. It is unmoving, permanent, a silent backdrop against which every event unfolds. That stage, Newton declared, is time. Think of the kitchen clock hanging on a wall. It ticks whether you glance at it or not. Your day might rush by or drag slowly, but the clock is indifferent. Its hands circle with mechanical precision, carrying on regardless of your feelings. Newton imagined the universe itself as operating under a similar principle. Time ticked on like a universal clock, indifferent to the dramas of the world. A cannonball arcing through the air, a planet circling the sun, a cart rolling down a slope. All could be described with laws that assumed time marched forward at the same pace everywhere. This view fit beautifully with the physics Newton was building. His laws of motion required a steady framework in which to play out. Force equals mass times acceleration. Such an equation makes sense only if time is uniform, if seconds here are the same as seconds there. Under Newton's absolute time, scientists could calculate, predict, and control with breathtaking accuracy. The planets danced to precise equations, pendulums obeyed predictable swings, tides rose and fell with calculable rhythm. For more than 2 centuries, this picture was not only dominant, it was deeply comforting. The universe was a vast machine, and time was its perfect metronome. There was also something reassuring about Newton's absolute time for ordinary people. If time was universal, then when a church bell rang noon in London, it was truly noon everywhere, whether or not anyone was awake to hear it. There was a single cosmic clock, and we were all moving to its beat. Philosophers found in this vision a kind of stability, a sense that the world had an underlying order that did not depend on fragile human perception. The seconds that carried your breath forward were the same seconds that carried the stars across the night sky. But Newton's idea was not without its challenges. His contemporary, Gottfried Wilhelm Leibniz, argued that time might not exist independently, but only as a relation between events. Without events, what would time be? If nothing changed, would time still pass? To Leibniz, time was not a stage but a relationship, a way of describing how one thing happened before or after another. Yet for generations, Newton's view prevailed. The universality of his mechanics, the success of his equations, and the predictability of his celestial clockwork were too powerful to ignore. It is worth pausing to imagine what Newton's universe felt like. Picture yourself standing in a meadow. Above you, clouds drift. A bird crosses the sky. A breeze moves through the grass. Each motion, each change, happens within an invisible container of time that flows steadily, like water in a vast unseen river. You cannot slow it, you cannot speed it, and no matter where you travel in the universe, you are always carried forward at the same rate. It is impartial, unavoidable, eternal. For daily life, this view still feels natural. You glance at your watch, and you assume its seconds match those of a clock across the world. You set a meeting at 9 in the morning, and you trust that 9 a.m. in your town is the same 9 a.m. on your colleague's calendar elsewhere. Absolute time still lingers in our language and assumptions. We talk of saving time, losing time, or running out of time, as if it were a substance, universally shared and steadily consumed. Newton's backdrop made sense because it worked. It explained why apples fall, why the moon circles Earth, why tides follow the pull of the sun and moon. His model described a cosmos of reliability, where every motion could be traced, every future predicted, if only you knew the present with enough detail. Laplace, a later mathematician, would famously imagine a great intelligence, sometimes called Laplace's demon, that, knowing all the positions and velocities of every particle at a given moment, could calculate the entire past and future of the universe. Such confidence in determinism depended entirely on Newton's steady backdrop of time, and yet, even in Newton's day, hints of complication lurked. The rotation of Earth was not perfectly uniform, days lengthened or shortened ever so slightly. Pendulum clocks needed corrections as they shifted with temperature. Astronomers noticed tiny discrepancies in planetary orbits that hinted at complexities not captured by a perfectly rigid stage. These were small cracks in a model that, for most purposes, seemed unshakable. As you listen tonight, you may feel the allure of Newton's vision. It offers certainty. It offers the comfort of a universe running like a perfect clock, with time flowing forward in unbroken rhythm. And perhaps, when you lie awake at night and hear the steady tick of a clock on your nightstand, it still feels like proof that time is absolute. Each tick, each tock is a reminder that the world is steady beneath the chaos of daily life. But soon, in the 20th century, this certainty would be challenged. A young physicist named Albert Einstein would propose that Newton's backdrop was not so solid after all. Time, far from being absolute, could bend and stretch, depending on speed and gravity. Seconds were not the same for everyone, everywhere, but relative, shifting, pliable. The great stage Newton imagined would dissolve into a flexible fabric, and with it, the comforting notion of universal time would be forever changed. For now, let us linger in Newton's universe a moment longer. Imagine that steady stage, vast and still, carrying everything upon it. Picture the planets circling like dancers on a floor that never wavers. Feel your own heartbeat as part of that cosmic rhythm, steady as a pendulum. There is a quiet comfort in the thought that, for centuries, this was how humanity understood time, a backdrop both silent and strong, the most reliable friend in the universe. For more than 2 centuries after Newton, the idea of absolute time seemed unshakable. It had given the world order, predictability, and confidence. But at the dawn of the 20th century, cracks began to widen in the stage he built. Scientists studying light found puzzling inconsistencies. No matter how fast an observer moved, light seemed to travel at the same speed. Newton's steady backdrop, so long trusted, no longer fit. Into this unsettled landscape stepped Albert Einstein, a young patent clerk with a restless mind and a fondness for thought experiments. What he proposed was not a small correction to Newton's stage, but a reimagining so profound that it changed our understanding of time forever. Einstein's special theory of relativity, published in 1905, introduced a daring idea. Time is not absolute. It does not tick the same for all observers. Instead, it depends on motion. If you are standing still and I am racing past at nearly the speed of light, our clocks will not agree. From your perspective, mine will run more slowly. From mine, yours will seem to lag. Time itself stretches and compresses depending on speed. This phenomenon, called time dilation, is not just a quirk of mathematics. It is real, measurable, and has been confirmed in countless experiments. Imagine twins. One remains on Earth while the other boards a spaceship and travels close to the speed of light. When the travelling twin returns, they will be younger than the sibling who stayed home. This twin paradox may sound like science fiction, but it follows directly from Einstein's equations. Motion changes the rhythm of time, and it is not only speed that bends time. A decade later, Einstein's general theory of relativity added gravity to the story. According to this vision, gravity is not a force pulling objects across empty space, but the curvature of space-time itself. Massive objects like stars and planets bend the fabric of the universe, and time flows differently depending on how close you are to that curve. The stronger the gravity, the slower time passes. A clock at the bottom of a mountain ticks more slowly than one at the summit, though the difference is vanishingly small. Even your head experiences time ever so slightly faster than your feet, because it is farther from Earth's gravitational pull. To picture this, Einstein offered a metaphor that has since become iconic. Imagine space-time as a vast, flexible sheet of rubber. Place a bowling ball on it, that is the sun, and the sheet dents. Roll a marble nearby, that is Earth, and the marble spirals inward, not because it is being pulled, but because it follows the curve of the sheet. In the same way, planets orbit stars and stars orbit the centres of galaxies, but the sheet is not only space, it is time as well. Clocks placed near the bowling ball tick more slowly than those farther away. Gravity bends not just paths in space, but the flow of time itself. These ideas may sound abstract, but they ripple quietly through daily life. Take the global positioning system, the network of satellites circling Earth that tells you where you are when you open a map on your phone. Each satellite carries an atomic clock, but those clocks do not tick at the same rate as clocks on Earth's surface. They move faster because the satellites are farther from Earth's gravity, and they also move slower because they are travelling at high speeds. Both effects, special relativity's speed and general relativity's gravity, must be accounted for. If engineers ignored Einstein's corrections, GPS would drift by kilometres each day, and the simple act of finding a cafe would become hopeless. Without relativity, navigation would collapse. Einstein's flexible fabric also reshaped our imagination. The idea that time could stretch, bend and slow made the universe feel less like a machine and more like a living, shifting landscape. Time was no longer the steady beat of a cosmic drum, but a melody that could lengthen or compress depending on where you stood and how you moved. The comfort of Newton's universal tick was gone, replaced by something stranger, but also more beautiful. A universe where time and space are inseparable, woven together in a fabric that curves around stars, planets, and even you. It is worth lingering on the strangeness of this revelation. Imagine you're sitting on a train, watching the countryside roll by. To you, the train feels still, the coffee in your hand steady. But to someone standing outside, you're rushing past. In Newton's world, both of you share the same time, no matter your motion. In Einstein's world, your times diverge ever so slightly. The faster the train, the greater the difference. At everyday speeds, the gap is tiny, imperceptible. But as speed climbs toward light itself, the difference becomes vast. Time dilates, moments stretch, and the very rhythm of existence changes. Even more wondrous is the realization that the present is not universal. In relativity, simultaneity, the idea that two events happen at the same time, is not absolute. A flash of lightning striking two trees at once for one observer might not be simultaneous for another moving quickly nearby. The concept of a shared now, so central to human intuition, dissolves. Each observer carries their own version of time, shaped by motion and gravity. Reality becomes a patchwork of perspectives, stitched together by the fabric of space-time. And yet, despite the complexity, Einstein's vision does not feel chaotic. It has a quiet elegance, as though the universe were reminding us that order does not require rigidity. Time can bend without breaking, flow differently without dissolving. Perhaps that is why, even as relativity shattered Newton's certainty, it also inspired awe. The universe became stranger, but also richer, more intricate, more alive. Tonight, as you rest, you might picture yourself lying on that great sheet of space-time, the weight of Earth beneath you making its own small dent, stars above carving deeper wells. Time flows through this fabric like a river winding through valleys and hills, slower here, faster there, never uniform, always shaped by the contours of mass and motion. You're not separate from it, you're carried by it, every heartbeat and every thought flowing along its curves. Einstein once said that the distinction between past, present, and future is only a stubbornly persistent illusion. Whether he was right remains a matter of debate, but his equations tell us this much with certainty. Time is not absolute, not a steady backdrop. It is flexible, pliant, and deeply woven into the structure of the universe itself. If Einstein showed us that time bends and stretches, black holes reveal just how far that bending can go. They are the universe's most extreme laboratories, where the fabric of space-time is twisted into shapes so strange that even light cannot escape. To study them is to walk to the very edge of time itself, where moments lengthen into eternities, and the familiar flow of seconds nearly comes to a halt. Imagine a massive star, far heavier than our sun, burning through its fuel across millions of years. When its nuclear fire finally fades, the star collapses inward, its own gravity pulling tighter and tighter until all matter is crushed into a single point. Around that point lies the event horizon, a boundary beyond which nothing can return. It is not a wall you could touch. It is a horizon in the truest sense, marking the place where the universe itself turns inward. For an object crossing this horizon, time and space trade places. Inside, every path leads not outward, but deeper toward the singularity. From a safe distance, you might watch an astronaut fall toward such a horizon. As they approach, you would see their motion slow, their signals stretch, their very heartbeat delayed. To you, standing far away, time for them seems to freeze at the edge. They never quite cross. Their image fades, red-shifted into darkness, until they vanish. But from the astronaut's perspective, the story is different. They feel themselves falling smoothly, crossing the horizon without noticing a boundary. Their clock ticks as always, their breaths and thoughts flowing normally. The contradiction is only in perspective. Time, relative and flexible, creates two realities, one for the observer far away, and another for the traveller who dares the fall. This strange duality is not speculation. It arises directly from Einstein's equations. Gravity slows time, and black holes are gravity at its most extreme. Place a clock near a black hole, and it will tick more slowly than a clock kept farther away. Place yourself there and you would not feel slower. To you, everything would seem normal, but the rest of the universe would rush ahead. Stars would age, galaxies would evolve, and eons might pass in what feels to you like a handful of minutes. The black hole does not destroy time, it distorts it until it becomes nearly unrecognizable. Even our own planet gives us a hint of this effect. Satellites orbiting Earth experience time slightly differently than we do on the surface. Their clocks tick faster because gravity is weaker at their altitude. The difference is tiny, nanoseconds each day, but it must be corrected for GPS to function. Near a black hole, that tiny difference becomes immense. Hours for you might be millennia for the universe beyond. A gentle hike near the event horizon could mean returning to a cosmos utterly changed. The idea that time nearly stops at the horizon has inspired countless stories, from films to novels, but in reality what lies within remains hidden from us. The laws of physics, as we know them, break down at the singularity. Equations collapse into infinities, and our theories, so carefully built, lose their power. Some physicists believe quantum mechanics will one day resolve the mystery, smoothing out the singularity into something comprehensible. Until then, the heart of a black hole remains a silence in our knowledge, a dark place where time itself may lose meaning. And yet, there is something profoundly peaceful about the thought. A black hole, for all its destructive reputation, is also a place of stillness. Imagine drifting near its horizon, your spacecraft hovering on the edge. Outside, the universe is rushing forward, galaxies spinning, stars exploding, civilizations rising and falling, but for you, time has slowed to a crawl. Every second is stretched, every moment elongated. The black hole becomes less a monster and more a sanctuary, a reminder that time is not fixed but fluid, that the cosmos has corners where eternity lingers. There is also beauty in the way black holes bend not only time, but light itself. Their gravity warps space so deeply that light curves around them, creating rings and arcs in the sky. If you could gaze from near the horizon, you would see the universe distorted into strange looping images. Stars would appear in multiple places at once, their light bent into circles. Time and vision would blur together, a reminder that our senses, so accustomed to Earth's gentle gravity, are not built for such extremes. Astronomers today do not merely imagine these effects. With the Event Horizon Telescope, they have captured images of black holes, the great shadow at the centre of galaxy M87, and the quieter silhouette of Sagittarius A star, the black hole at the heart of our own Milky Way. These cosmic portraits are not just photographs, they are glimpses into the deep truth of relativity. The shadows we see are carved not only by space, but by time itself slowing and folding at the edge. When you lie awake tonight, consider this. The same laws that bend time near a black hole are at work in your own life. Gravity here on Earth is gentle, but it still slows time. Your feet, closer to the ground, age imperceptibly more slowly than your head. The effect is laughably small, yet it connects you to the same principle that rules the darkest giants in the cosmos. In every moment, from satellites in orbit to light struggling at an event horizon, time reveals its pliability, its willingness to bend under the weight of the universe. Einstein's equations led us here, to this place where seconds and centuries can mingle, where one observer's instant is another's eternity. Black holes are not only astronomical objects, they are philosophical ones. They remind us that time is not absolute, not universal, not steady. It is stitched into the fabric of space, pulled and twisted by mass and motion, until even the word now loses its certainty. And yet, even with all this strangeness, you are still here, breathing gently, feeling the rhythm of your heart, carried forward by time at its ordinary pace. The black hole may bend it, the cosmos may stretch it, but in this quiet moment, your seconds are steady. They are yours. And perhaps that is the most profound lesson of all. Time, whether rushing or crawling, whether stretched near a horizon or ticking in your bedroom, is always experienced as now. So far, we've wandered through Newton's steady clockwork and Einstein's bending fabric, each framework vast enough to shape centuries of thought. Yet both rest on a certain assumption, that time itself exists, that it flows or stretches, that it can be measured like a river's current. But when physicists peer into the quantum world, the realm of particles smaller than atoms, that assumption begins to wobble. At this scale, time does not behave like the flowing backdrop we feel in daily life. It is not even treated as a thing in the same way space, momentum, or energy are. Instead, it slips quietly into the background, like a stagehand in a play, necessary but curiously absent from the spotlight. In quantum mechanics, time is not an operator, it is a parameter. That may sound like a technical distinction, but the difference is profound. Operators in quantum theory represent measurable quantities: position, momentum, spin. You can ask where a particle is, or how fast it moves, and the theory will give you probabilities. But time is not granted the same role. It is not something you measure, it is something you reference, a coordinate against which changes unfold. You do not ask, what is the value of time? You ask, what is the value of position at a given time? In this way, time seems less like an entity and more like a bookkeeping device. Imagine beads of light blinking on and off in a dark room. Quantum mechanics tells us the pattern of blinking, the probabilities of where the next spark will appear. But time itself, the rhythm of when those sparks occur, is simply assumed, as though an invisible metronome were ticking outside the theory. This treatment works beautifully for experiments, predicting with uncanny accuracy how atoms, photons, and electrons behave. Yet it also leaves a troubling question. If time is so fundamental to our experience, why does quantum mechanics treat it as little more than a label? Some physicists argue this gap reveals a deeper truth. Perhaps time is not fundamental at all. Perhaps it emerges from the relationships between events rather than existing on its own. If nothing changes, if no particles interact, what meaning would time have? In this view, time is born out of difference. The way one state becomes another, the way particles exchange energy, the way a system evolves. Without events, without change, time loses its meaning. This perspective can feel slippery, even unsettling, because it suggests that our most intimate experience, the steady march of moments, is not built into the universe but stitched together by perception. And yet, it echoes ancient questions. Augustine once wondered if time would exist at all if nothing were happening. Quantum mechanics gives that intuition a sharper edge. The equations run without granting time a central place, as if whispering that time may be more fragile than we thought. There are other puzzles too. Quantum mechanics famously involves measurement. A particle exists in a haze of possibilities until you observe it, and then its state becomes definite. But when does that collapse occur? Does it happen in an instant? If so, what is an instant? If time itself is not fundamental, how can we even speak of something happening at a precise moment? The theory works, yet the language falters. For everyday life, these questions may seem remote, but their implications ripple outward. Consider that all the physics describing the largest scales, the bending of galaxies and the ticking of GPS satellites, rests on relativity, where time is flexible but still present. All the physics describing the smallest scales, the flicker of particles, rests on quantum mechanics, where time is more of a background parameter than an active player. To unite these two great pillars of science into one coherent picture, we must also decide what to do with time. Is it real, flowing, fundamental, or is it a shadow cast by something deeper? To ease the mind around this, think of music. A melody feels like it unfolds in time, but the notes themselves written on a page are all there at once. When you play them, your perception stitches them into a song. Quantum mechanics hints that the universe may be more like the page than the performance, with time arising as we move through the notes. The music is real, but the flow of it may be an illusion created by the way we listen. It is a gentle, humbling thought. We are so used to time being the most basic of realities. You wake, you eat, you breathe, you sleep. The sun rises, the sun sets. But at the deepest levels of matter, the equation suggests time is not written into the fabric at all. It is something we experience because we live in a universe full of change, because we carry memories of the past and expectations of the future. Without memory, without change, perhaps there would be no sense of time at all, only a quiet stillness. So as you rest tonight, imagine the universe at its smallest scales, where particles shimmer in superpositions, where outcomes hover in probabilities. In that strange theatre, time does not stride confidently across the stage. It waits in the wings, silent and hidden, its role less certain than you might have thought, and perhaps, like a dream you can barely remember upon waking, the flow of time itself is something your mind creates in order to make sense of the flickering of reality. When you hear the word loop, you might think of a circle of string, or perhaps the familiar loop of a melody playing again and again. In physics, the word carries a similar sense. The idea that at the most fundamental level, reality might not be a smooth fabric, but a collection of loops, tiny discrete structures interwoven like threads. This vision is known as loop quantum gravity, and it offers a picture of the universe that challenges not only how we think of space, but also how we think of time itself. Loop quantum gravity arose from an attempt to reconcile two great but seemingly incompatible pillars of physics: Einstein's relativity, which describes gravity and space-time on cosmic scales, and quantum mechanics, which governs the tiny particles dancing at the heart of atoms. Relativity insists that space-time is smooth, curving elegantly under the weight of stars and planets. Quantum mechanics, on the other hand, teaches us that energy and matter often come in quanta, discrete packets, indivisible and fundamental. When scientists tried to unite these frameworks, they found contradictions. Equations spiraled into infinities, the harmony of physics cracked, and time itself became one of the most puzzling notes. In loop quantum gravity, space is not a continuous stage but a network of finite loops, woven together into a vast, intricate web. Imagine a tapestry viewed up close, where each thread reveals itself, or the pixels of a digital screen, invisible from afar but undeniable when magnified. Just as a picture on your phone is made of discrete dots, so too might the universe be made of discrete units of space. If this is true, then time, traditionally thought of as continuous, endlessly divisible, might not exist at the fundamental level. Instead, what we perceive as time may emerge from the way these loops change in relation to one another. The physicist Carlo Rovelli, one of the most influential voices in this field, often describes time not as a flowing river, but as something more relational, more emergent. In his view, time is not a universal ticking clock, but a story we tell about change. To say time passes is simply to say things happen. The loops of space rearrange, energy shifts, particles interact, and in their change, we perceive the flow of time. Without change, there would be no time at all, only stillness, only silence. Rovelli has gone further, suggesting in his thermal time hypothesis that what we call time arises from the statistical properties of systems, from entropy and disorder. In this picture, time is not fundamental, but a byproduct of how systems evolve toward equilibrium. It is as though time is the smoke rising from a fire, not the fire itself. The smoke is real, visible and significant, but it depends on the burning beneath. Remove the burning and the smoke vanishes. Remove change and time disappears. This is not an easy vision to sit with, especially when you feel so intimately the passing of moments. You recall your childhood, you look forward to your future, you feel the weight of minutes ticking on a clock. And yet physics whispers that perhaps these feelings are the result of deeper processes, not reflections of something fundamental. What you call now may be a local phenomenon, shaped by perspective, memory and entropy. The universe itself may not be flowing through time, it may simply be changing timelessly. To make sense of this, think again of music. When you listen to a symphony, you hear notes unfolding in order, and it feels like time is carrying them forward. But on the page, the entire composition exists at once. Nothing is flowing, the sequence is written. It is only when the music is played, when you move through it, that you experience the melody. Similarly, the universe might be more like the sheet of music, complete, whole, timeless. What you call time is your experience of moving through the notes, your consciousness interpreting change as a flow. The thought is dizzying, but it also carries a certain peace. If time is not fundamental, then perhaps its flow is not as merciless as it seems. The past is not lost, the future not yet created. Everything may exist together, in different relations, in different configurations of loops. You're not falling helplessly through a current. You're simply part of a vast web of change, your own story, one of countless patterns woven into the fabric. And yet, there is humility in recognizing that these ideas, beautiful as they are remain unproven. Loop quantum gravity is one of several attempts to unify physics. String theory offers another, suggesting tiny vibrating strings as the building blocks of reality. Both strive to answer the same riddle: how to reconcile quantum mechanics with relativity, how to find a single framework that explains both the smallest particles and the largest galaxies. Time, elusive as ever, sits at the centre of this riddle. When you close your eyes tonight, picture the loops that may underlie all of existence, shimmering like threads in a cosmic tapestry. Imagine them rearranging, shifting, dancing in silence. In their changes, you feel the passage of moments. In their relations, you sense before and after, cause and effect. But beneath it all, there may be no ticking, no flowing river, no universal clock, only loops, only relations, only change. And if that is the case, then perhaps the flow of time that you feel is not a cage, but a story. It is the narrative your mind tells as you move from memory to expectation, from heartbeat to heartbeat. The story is real, deeply felt, profoundly human. But it may not be the whole truth. The universe may be timeless, and yet here you are, nestled in its loops, carried by its change, experiencing what you call time. When you pour a glass of cold water and drop in a few ice cubes, you already know what will happen. Slowly, the cubes melt, spreading their chill into the liquid until the glass becomes uniformly cool. You do not expect the opposite, that the water will suddenly surrender its cold back into perfect cubes, rising from the bottom like crystalline sculptures. That reversal is not impossible by the laws of motion, but it is so improbable that it may as well be forbidden. This asymmetry is one of the quiet mysteries of the universe. Why does time move forward? Why do you remember the past but not the future? Why does a candle burn down instead of rising up into wax and wick again? The answer lies in entropy, the measure of disorder, and in the second law of thermodynamics, which whispers that, in an isolated system, entropy tends to increase. Think of entropy as a way of counting possibilities. A neat stack of cards has only one arrangement, while a shuffled deck can be combined in countless ways. The shuffled state is therefore more probable. Similarly, a room that begins tidy has few possible configurations, but as you live in it, clothes tossed on chairs, papers spread on tables, the number of possible states multiplies. The messy state overwhelms the neat one. Entropy grows. This growth of disorder gives time its arrow. You can play a video of a glass shattering and you know immediately whether it is running forward or backward. The shards gathering back into a cup betray the reversal, because that move runs against the natural tide of increasing entropy. Time, at its core, is not marked by clocks, but by the drift from order to disorder. And yet, entropy does not feel threatening when you encounter it in everyday life. Bread left on the counter grows stale, tea left on a table cools to room temperature, leaves scattered by the wind do not leap back into neat piles. Each of these changes is irreversible, pointing to the same direction. Forward. You might sweep the leaves into a pile or toast the bread to freshen it, but those actions require energy. You must push against entropy by expending effort. The universe itself leans toward disorder, while your attempts to reverse it come at a cost. Entropy also explains why you can stir milk into coffee but never unstir it. Once blended, the swirls of cream are lost, mixed into the dark liquid in patterns too fine to unravel. The order of separation has been replaced by the disorder of mixture, and that disorder is overwhelmingly more probable. The arrow of time is written in every cup of coffee, every melting ice cube, every kitchen that refuses to clean itself. But entropy is not only about messes, it is also about energy, about the way heat flows. A warm stone placed in cool water will release its heat until balance is reached. The direction of heat flow is what defines before and after. Without entropy, there would be no sense of past and future, only a static landscape where all processes could reverse as easily as they occur. entropy breaks the symmetry, ensuring that energy spreads, that structures decay, that time feels like a one-way street. The strange part is that the laws of physics, at their most fundamental, are symmetric. The equations describing how particles move do not care whether time runs forward or backward. If you filmed 2 billiard balls colliding and then reversed the footage, the motions would still look perfectly consistent with the laws of mechanics. And yet, when you add many particles together, when you think not of 2 billiard balls but of billions of molecules of air, a new rule emerges. Entropy tends to increase. This is not a law of possibility but of overwhelming likelihood. Why was the universe not already at maximum entropy from the beginning? Why do we live in a cosmos where order existed, allowing stars and planets to form before dissolving into equilibrium? That question reaches into cosmology, into the conditions of the Big Bang itself. The early universe seems to have been in a state of remarkably low entropy, smooth and ordered enough to allow structure to blossom. From that improbable beginning, entropy has been increasing ever since, carving the arrow of time into the cosmos. The melting of ice cubes, the cooling of tea, the dying of stars, all a part of that grand story. Consider the quiet comfort of this thought. When you watch the steam curl upward from a mug on a chilly morning, you're witnessing the same law that drives galaxies to spread apart, that pushes the universe toward its eventual fate. Your kitchen is linked to the cosmos by entropy's hand. The arrow of time, which seems so personal as you mark birthdays or watch your reflection age, is also cosmic, shared by every star and every grain of dust. And yet there is beauty hidden in disorder. Entropy does not only destroy, it also allows complexity. Stars burn because energy flows from hot to cold. Life thrives because energy gradients exist to be harnessed. The very fact that you can listen to this story, breathing in oxygen and releasing carbon dioxide, is because entropy permits processes that release energy for living systems. The arrow of time is not only decay, it is also creation. A sculptor carving possibilities from the flow of change. So tonight, as you rest, you might think of entropy not as an enemy but as a gentle current. It is the reason tea cools, but also the reason fires burn warm. It is the reason bread goes stale, but also the reason you can bake it fresh in the first place. Entropy is the quiet assurance that tomorrow will not look like yesterday in reverse, but like something new carried forward. It is the universe's reminder that time is not a loop circling back, but a road that stretches ahead, ever winding, ever opening. If entropy explains why ice melts and tea cools, it also whispers to us why we remember the past but not the future. Think of your own memories. You can recall last year's summer evening, the colour of the sky, the laughter of friends, but you cannot recall next year's. You can imagine it, dream it, plan for it, but not remember it. Why does consciousness face backward and not forward? This puzzle is known as the psychological arrow of time, and though it feels deeply personal, it is tied to the same laws that guide the stars. Memory is, at its root, a record of change. Neurons rearrange connections, strengthening or weakening them, leaving traces of experience in their patterns. These traces point back towards states that once were, not states that will be. The arrow points that way because entropy does. When an egg falls and shatters on the floor, the pieces tell you the past. They were once whole, but they tell you nothing certain about the future. Entropy moves forward, and memory, like a shadow, follows behind. This link between entropy and memory is not just poetic, it is practical. To record information, to make a memory, your brain must expend energy, leaving traces that increase entropy elsewhere. The very act of remembering has a cost, and that cost reinforces the one-way street. If entropy were not increasing, memory itself might have no direction, and you might recall the future as easily as the past. But you do not. You live in a world where tea cools, where leaves scatter, where records are carved only backward. Connected to this is the causal arrow of time, the rule that causes precede effects. You strike a match, and then a flame appears. You do not see a flame burst forth, and then watch your hand reach to strike the match afterward. The order of cause and effect seems absolute, inviolable, and yet the equations of physics, if taken on their own, do not forbid the reverse. If you reversed all velocities, particles would retrace their steps, and effects would seem to cause their causes. The only reason we do not see this is entropy. The universe's drift toward disorder anchors causes before effects, ensuring that matches light after they are struck, not before. Consider the simple act of dropping a ball. It falls, it bounces, it rolls to a stop. Each stage follows naturally from the last, and you never see it roll backward of its own accord, leaping into your hand. You could imagine a reverse film showing just that, and the equations would not forbid it. But the improbability is astronomical, so high that in practice it never occurs. The arrow of causality, like the arrow of memory, is a child of entropy, born from the asymmetry of probabilities in a universe tilted forward. Beyond memory and causality lies another arrow, the cosmological arrow of time, written not in neurons or matches but in galaxies. Look up at the night sky, and you see galaxies receding from us, the universe expanding like dough rising with raisins inside. This expansion, discovered by Edwin Hubble in the 1920s, tells us that the cosmos was once smaller, denser, hotter. It had a beginning. And ever since that beginning it has stretched outward, carrying galaxies apart like boats drifting on a vast sea. This expansion gives direction to time on the grandest scale. If the universe were contracting, shrinking into itself, the arrow might point the other way. But it is not. It is swelling outward, entropy increasing, structures forming and dissolving in a cosmic drift toward equilibrium. The arrow of time is cosmic as much as it is personal, woven into the very fabric of the universe. It is humbling to realize that the same principle guiding your memories guides the stars. When you look at an old photograph, when you feel nostalgia for a moment long gone, you are obeying the same law that pushes galaxies apart. The candle that burns, the match that strikes, the neurons that remember, the cosmos that expands. They are all threads of the same tapestry stitched together by entropy, pointing always forward. And yet, this forwardness is not bleak. It is not only decay. The arrow of time allows stories. It allows beginnings, middles, and ends. Without direction, life would be a jumble of moments, unstrung beads with no necklace to bind them. The fact that time flows forward allows you to be a character in a story, to grow, to learn, to hope. It allows meaning to unfold. Imagine a library filled with books. Each page is filled with words, each word fixed on the paper. You could flip the pages backward or forward, and the ink would not change. But to read the story, you must move forward, page by page. That forwardness is what gives the tale its power. The universe may be like that library. All the pages exist, but you experience them in order, carried forward by entropy's hand. So tonight, as you settle into the stillness of your room, think of how many arrows point you forward. Your memories reach back, never ahead. Causes lead to effects, never the reverse. Galaxies recede, stars drift apart, the cosmos itself expands. Time does not simply flow, it leans. It leans forward, always, from the smallest neuron to the largest cluster of galaxies, and you, resting here, are part of that lean, carried on a current that began billions of years ago and still flows through your breath, your thoughts, your dreams. If the universe carries its arrow of time through entropy and expansion, your body carries its own rhythm in ways no less profound. Within you, deep in the folds of the brain, lies a tiny cluster of cells, only about 20,000 in number, called the suprachiasmatic nucleus, or SCN. Nestled just above where the optic nerves cross, this small structure serves as your master clock, conducting the symphony of your circadian rhythm. With no sound and no baton, it nonetheless guides the tempo of hormones, sleep, hunger, and alertness. The word circadian comes from the Latin circa diem, meaning about a day. It is a cycle of roughly 24 hours, tuned not by chance but by sunlight. When dawn arrives and light strikes your eyes, the signal travels along the optic nerve to the SCN. There, in quiet pulses, your master clock resets itself. Darkness tells it one story, light tells it another. Your body listens, adjusting its rhythm to match the turning of Earth. Imagine yourself waking on a clear morning. The curtain slightly opens so that sunlight spills softly across the room. You stretch, yawn, and feel the tug of alertness return. This is no accident. The light suppresses melatonin, the hormone of sleep, and signals your body to release cortisol, sharpening attention and preparing muscles to move. The day has begun, and though you may think it is willpower that gets you out of bed, it is as much the SCN, the conductor nudging your orchestra into action. Throughout the day, this internal clock shapes your energy. Mid-morning may bring peak alertness, ideal for problem solving. Afternoon might dip into sluggishness, a reminder that even in the brightness of day, your body still carries an ancient rhythm of rest. Evening comes, and melatonin rises once again, coaxing you towards sleep. The cycle repeats, an endless loop of wake and rest, tied not just to the sun above, but to the quiet ticking of genes and proteins inside your cells. Yet not everyone's orchestra plays the same tempo. Some are morning larks, rising with enthusiasm at dawn, their clarity sharp in the early hours. Others are night owls, their minds brightening long after sunset when the world grows quiet. These chronotypes are not choices but variations written into biology, shaped by subtle differences in the body's clock. You may envy a friend's energy at sunrise, or marvel at another's creativity after midnight, but both are simply expressions of the circadian symphony, each with its own rhythm. Consider how society often leans toward the lark, structuring schools and jobs around early mornings. For night owls, this creates friction, a dissonance between body and obligation. The struggle to stay alert in morning meetings is not laziness, but biology fighting against an imposed rhythm. Over time, that mismatch can ripple into health, affecting mood, metabolism, even cardiovascular function. Time, after all, is not just what the universe does, it is what your cells do moment by moment. Even beyond the SCN, clocks exist in nearly every cell of your body. Genes switch on and off in daily cycles, orchestrating everything from liver function to muscle repair. These peripheral clocks take their cues from the master clock but also respond to meals, exercise, and habits. Eat late at night, and your digestive clock shifts. Exercise in the morning, and your muscles listen. In this way, your body is not governed by a single ticking hand but by a whole ensemble, coordinated yet flexible, adapting to the rhythms of life. Imagine walking through a city at dusk. Streetlights flicker on, people head home, kitchens fill with the sounds of dinner. All around, circadian rhythms are at work, melatonin rising, body temperatures cooling, alertness fading. The entire city hums with invisible cycles, each person carrying their own clock within, each clock tuned by light, food, and habit. You cannot see it, but it is there, a great symphony unfolding every evening. There is a certain comfort in knowing this. Even when you feel adrift, even when days blur together, your body carries this rhythm faithfully. It whispers in hormones, it pulses in neurons, it steadies your heartbeats and breaths. You are part of a cosmic cycle larger than yourself, tied to the turning of Earth beneath the sun. Time is not only a number on a clock face, but a melody playing in your cells. and perhaps that is why disruptions to the circadian rhythm feel so jarring. Shift workers who move against the natural cycle, students who stay up late and wake too early, travellers who cross time zones, each feels the strain of a symphony out of sync. The body protests, sometimes gently with fatigue, sometimes more fiercely with illness. To live in harmony with your circadian rhythm is to live in harmony with time itself, at least the kind of time that beats within you. As you lie in bed tonight, you are listening not only to this story, but to your own circadian clock, preparing you for rest. The SCN has dimmed the orchestra, melatonin has risen, your body temperature has lowered. You're carried towards sleep not by chance, but by a rhythm older than civilization, older than memory, older than language. It is the same rhythm that guided ancestors who lit fires at night, who woke with dawn, who trusted the sky to tell them when to work and when to rest. The circadian symphony is still with you now, humming quietly, reminding you that time is not only cosmic or physical, but biological and intimate. It beats in your cells, it guides your days, it holds you in its embrace as night folds around you. As daylight fades, the circadian symphony begins to play its evening movement, and the lead instrument is a quiet hormone called melatonin. While cortisol lifts you into alertness in the morning, melatonin gently lowers you into rest at night. Secreted by the pineal gland, a small structure nestled deep within the brain, melatonin is sometimes called the hormone of darkness. It rises when light disappears, telling your body it is time to prepare for sleep, to soften its rhythms, to retreat from the busyness of the day. Imagine yourself sitting in a living room as dusk gathers outside. The sky shifts from gold to violet, then to deep blue. As the last streaks of sunlight fade, melatonin begins to trickle into your bloodstream like a slow stream filling a quiet lake. You may not notice it at first, but within an hour or two your eyelids feel heavier, your thoughts drift more slowly, and the day seems ready to release you into dreams. This is melatonin at work, synchronizing your body's inner clocks with the world's natural rhythm of night and day. Light, however, is the master switch. The same optic nerves that carry sunlight's message to your suprachiasmatic nucleus also tell your pineal gland when to begin releasing melatonin. Bright light suppresses it, darkness allows it to flow. This is why sitting before a glowing screen late at night can trick your brain into thinking it is still daytime. The blue light emitted by phones and laptops is particularly effective at silencing melatonin, leaving you restless even when your body craves rest. The simple glow of a screen becomes enough to confuse the orchestra, delaying the night's lullaby. Travel offers another glimpse of melatonin's power. Picture yourself boarding a plane in New York in the evening and landing in Paris the next morning. The clock on the wall insists it is day, but your body believes it is still night. Your melatonin rhythm lags behind, still synced to your departure point. This mismatch is jet lag, the dissonance between your inner clock and the external world. You yawn in bright cafes at noon, lie awake in dark hotel rooms at midnight, because melatonin has not yet caught up. Over several days, with exposure to local light, the rhythm resets, and the hormone once again guides you gently into night. Shift work creates an even harsher battle. Nurses, pilots, factory workers, many live by schedules that invert the natural cycle of light and darkness. They sleep in daylight and work under artificial lamps at night. For them, melatonin often arrives at the wrong times, rising when they need to stay awake, failing to appear when they long for rest. Over years, this discordance can affect health, leading to fatigue, metabolic issues, and increased risk of disease. The orchestra cannot play its symphony properly when the conductor is misled by light that never dims. Yet melatonin is not only about sleep. Its influence touches many systems. It regulates immune function, acts as an antioxidant, and even plays roles in reproductive health. In medicine, synthetic melatonin is sometimes used to ease insomnia, to help shift workers adjust, or to soften jet lag's blow. Still, it is not a sedative. It does not force sleep so much as signal readiness. It is the body's gentle whisper that night has arrived. Consider how powerful this whisper is. Even without clocks, even without knowledge of hours, people placed in caves with no sunlight fall into rhythms of wake and sleep that last close to 24 hours, guided by internal cycles and melatonin's rise and fall. The hormone does not dictate every detail, but it is one of the strongest hands guiding your inner sense of night and day. There is a certain poetry in this. Melatonin is invisible, silent, and yet it shapes one of the most profound transitions of your daily life, the surrender to sleep. Each night as darkness falls, a tide rises in your bloodstream carrying you toward dreams. You do not need to will it into existence. It comes on its own, part of the same ancient rhythm that guided your ancestors when they gathered around fires and looked up at star-filled skies. And so, as you sit tonight, perhaps listening to this with the lights dimmed, your melatonin is likely already rising. Your body is listening to the darkness, preparing to rest. Outside, the world is quieter. Shadows stretch across the streets, and above it all, the night sky reminds you that this cycle has turned unbroken for billions of years. The sun falls, melatonin rises, and your body enters the embrace of time's gentlest rhythm. If circadian rhythms and hormones guide the grand cycle of day and night, then the heart offers a quieter, more personal metronome. It beats steadily within you, moment by moment, ticking not in hours but in pulses, about 100,000 times a day. This rhythm is so familiar that you rarely notice it, yet it is as fundamental to your perception of time as the sun rising outside your window. Every beat, every thump, every pause is part of the music of your life, a constant reminder that you are carried forward not only by cosmic arrows and biological clocks, but by the drumbeat of your own body. Imagine pressing a hand lightly against your chest and feeling the pulse beneath. It does not matter if you are aware of Newton's absolute time or Einstein's relativity. This is the time that matters most in that moment. A second feels like a beat, a breath like a phrase, and together they weave the fabric of your present. From the first heartbeat before you drew breath to the final one at life's end, this rhythm has never ceased. It has been your most faithful timekeeper, marking moments when you were asleep, when you were rushing, when you were still. Breathing too offers a rhythm. Inhale, exhale, the tide of air filling and leaving your lungs. Most adults breathe around 20,000 times per day. Each breath is shorter than the span of a heartbeat, but together they form a cadence, a background against which thought and action unfold. In meditation, when people slow their breathing deliberately, they often report that time itself seems to soften. The rhythm of breath and heart sets the pace at which you experience the world. Scientists studying perception have found that internal rhythms like heartbeat and breathing can influence how you feel time passing. When your heart races with fear, moments stretch and slow, as though the world itself is delaying to match your urgency. When your heart relaxes and your breath steadies, time feels more fluid, less pressing. In this way, biological rhythms are not only clocks but filters, colouring the flow of seconds with emotion. Consider how this plays out in daily life. A child waiting for a holiday counts the hours with restless energy, each moment stretched by excitement. Their heart beats quickly, anticipation pushing their sense of time wide open. An adult, busy with work, feels the same days vanish in a blur, the heart steady, the mind distracted. Two lives in the same 24 hours, but two entirely different perceptions, both anchored by the same circadian rhythms, both carried by the same heartbeat, yet painted with different colours of experience. The heart is not only a clock, it is also a memory keeper. Studies have shown that people often remember moments when their heartbeat surged, a sudden fright, a burst of laughter, a moment of awe. The rhythm marks experience, carving certain events more deeply into memory. This is why you may recall the sensation of your chest pounding during a speech or a fall, even years later. Your inner metronome becomes part of the story, embedding time in sensation. There is poetry in the idea that your body carries not one clock but many. The SCN sets the daily cycle, melatonin guides the night, and the heart ticks with every beat. Muscles, liver, lungs, all carry rhythms of their own. Together they form a polyphony, a layered song of clocks that keeps you not just alive, but attuned to the passage of time. The rhythms sometimes clash, sometimes harmonize, but always continue, weaving the narrative of your days. Picture yourself lying in a quiet room, no ticking clock on the wall, no phone glowing nearby. Close your eyes, and all you hear is your own heartbeat and the rise and fall of your breath. That too is time. It is not measured in hours or minutes, but in the living rhythm of your body. Long before sundials and pendulums, before Newton and Einstein, this was how creatures felt time, in the pulsing of veins, in the tides of lungs, in the slow beat of life itself. Perhaps that is why music feels so natural. Drums, flutes, songs, all follow patterns that mirror the rhythms within you. When you listen to music, you often tap your foot, nod your head, align yourself with the beat. In those moments, the line between external time and internal time blurs. You're not simply listening, you are resonating, your heart and breath adjusting, your body syncing with a pattern outside itself. Time becomes not a number but an experience, a shared rhythm, and there is comfort in knowing that this rhythm is steady. Even when your thoughts race, even when you feel lost in the rush of daily demands, your heart continues its beat, your lungs their tide. They hold you steady, grounding you in the present. While physics may argue over whether time is fundamental or emergent, whether it flows or simply exists, your body assures you that it moves, beat by beat, breath by breath. As you drift towards sleep tonight, you may notice your heartbeat slowing, your breathing deepening. The rhythm softens like music reaching its closing notes. You're not separate from the passage of time, you are its instrument, playing quietly, unceasingly until the final measure. And perhaps that is the gentlest truth of all. Time is not only out there in stars and equations, it is within you, pulsing, steady, always carrying you forward. When you think of the present moment, you may picture it as razor thin, a knife's edge between past and future. But your experience of now is not so narrow. The present, as you feel it, is a span of time stitched together by your mind, what philosophers and psychologists call the specious present. Rather than a single point, it is a window, perhaps 2 or 3 seconds long, in which perceptions blend into a continuous experience. Without this stitching, life would not be smooth, it would be fractured, a series of isolated snapshots without melody or flow. Consider music. A single note is not a melody. If your mind could only experience one note at a time, the beauty of a song would vanish. What makes music possible is the fact that your brain holds several seconds of sound together, weaving them into a line that feels whole. The same is true of film. Movies are made of still frames, flashing 24 or more times each second. On their own, each frame is motionless, but your mind stitches them together, creating the illusion of fluid motion. Your sense of the present is, in this way, a kind of gentle trick, an act of continuous editing performed by the brain. This span of now is flexible. Sometimes it feels wide, holding more than a few seconds. At other times it narrows to an instant. Attention plays the role of sculptor. When you're absorbed, fully immersed in a conversation or a task, the present feels generous, like a space you can wander in. When you are distracted, it fragments, breaking into pieces that slip away before you can hold them. Time does not change, but your perception of it does, shaped by how your mind chooses to gather its threads. Imagine standing on a beach, watching waves roll in. Each wave takes a few seconds to crest and fall, and your mind holds those seconds together as a whole event. The foam rising, the crash, the retreat. Together they feel like one moment. But now imagine trying to notice every droplet of water. The flow dissolves, and what once seemed continuous becomes impossible to follow. Your present expands when you accept the whole, contracts when you focus on fragments. The specious present is the brain's gift of coherence, smoothing the rough edges of reality into something you can live inside. Scientists studying perception have measured this window in various ways. When volunteers are asked to tap in rhythm with a metronome, they can keep pace if the beats fall within a few seconds. If the gap stretches too long, they lose the rhythm, because the sense of now no longer bridges the interval. Similarly, when flashes of light are presented too quickly, the brain merges them into continuity. Too slow, and they feel separate. These experiments reveal that the present is not absolute, but stitched from intervals, a construction of the mind rather than a feature of the universe. Attention also alters the quality of this construction. A moment of boredom, waiting for a kettle to boil, staring at a clock second hand, feels stretched. The present becomes heavy, elongated, as though you're trapped in every tick. But a moment of joy, laughter with friends, a walk at dusk, feels light, fleeting, as if the present slipped by unnoticed. Both occupy the same span of seconds, but the way your mind stitches them gives them different weights. The specious present is elastic, bending to attention and emotion. There is also a limit to how finely you can divide the present. If a sound is interrupted for a fraction of a second, you often cannot detect the gap. Your mind fills it in, smoothing the experience. This is why phone calls with slight delays still feel continuous, why the rhythm of speech holds even when the signal falters. The brain prefers coherence to fragmentation. It edits reality, discarding precision in favour of flow. In doing so, it creates a present that is richer than the bare physics of time might allow. Think of the difference between a child and an adult. For children, the present often feels expansive. Summer days stretch endlessly, hours feel full, minutes linger. For adults, the present narrows, days blur together, weeks vanish in retrospect. Part of this is memory, but part is also the perception of now. Children's attention is wide and unfiltered. They gather more into each moment. Adults, accustomed to routine, compress the present, focusing on fewer threads. The specious present, though tied to biology, is also shaped by experience and habit. There is comfort in recognizing this. Time as measured by clocks may be rigid, but the time you feel is pliable. You can expand the present by slowing down, by paying attention, by letting moments breathe. A walk without hurry, a song listened to without distraction, a conversation with full presence, all stretch the specious present, making life feel fuller. You cannot stop the clock, but you can dwell longer in the now. As you lie here tonight listening quietly, you are already in a widened present. The words arrive in sequence, but your mind gathers them into a flowing stream, a story that stretches beyond individual sentences. You're not caught in the thin edge between past and future. You're resting in a small but generous window where moments blend. The specious present is your shelter, your way of smoothing the universe's fragments into a continuous lullaby. And perhaps, as your thoughts soften and drift, that window will widen into dreams where the present becomes something else entirely, timeless, non-linear, and free. If the specious present is the mind's way of stitching moments into a flowing now, memory is the loom that extends your sense of time backward, weaving past experiences into the story of your life. Without memory, you would exist only in the immediate, unable to recall yesterday or imagine tomorrow. It is memory that transforms the passing of seconds into the narrative of a lifetime, and yet memory is not a perfect recording. It is not a camera storing every detail to be played back at will. Instead, memory is a reconstruction, fragile and fluid, reshaped each time you call it to mind. Consider a childhood summer. Perhaps you remember long afternoons that seem to stretch endlessly, the sun high and golden, the air thick with warmth. You may recall laughter with friends, games played in the street, the feeling that days were abundant and unhurried. Now think of a recent summer. Weeks slipped by quickly, filled with work, errands and obligations. Why did the summers of childhood feel longer than those of adulthood, even though the calendar marks the same span of days? Part of the answer lies in memory. As children, everything is new, and the mind encodes new experiences with rich detail. Each day feels packed, and when remembered later, those details stretch time in retrospect. As adults, days often follow routines. The brain, efficient in its work, records less novelty, compressing the memory of weeks into what feels like a blur. Childhood summers feel expansive not because they were longer, but because memory painted them with more colours. This reconstructive nature of memory shapes not only the length of time, but its texture. Emotional events, whether joyful or fearful, often feel longer when remembered. Think of a moment of sudden fright, perhaps the screech of brakes before a near accident. In the moment, time itself seemed to slow. Later, when recalling it, the details are vivid: the sound, the angle of light, the pounding of your heart. The intensity stretched the memory, making it feel as though more time passed than truly did. Joy can have a similar effect. A day filled with celebration, laughter and warmth often feels longer in retrospect, each fragment preserved with care. Memory selectivity also means that the past is less certain than you might believe. When you recall an event, you're not playing back a recording but rebuilding it, filling in gaps with inference and imagination. Psychologists have shown that memories can be altered, details inserted or erased by suggestion. In this way, memory is both a time machine and a storyteller. It carries you backward, but the landscape it presents is a crafted one, not an exact map. And yet, imperfect though it may be, memory gives you identity. It allows you to say, I am the same person who walked here yesterday, even if your cells have changed, even if the world has shifted. Memory links the present to the past, creating continuity. Without it, each moment would be isolated, a disconnected island. With it, your life becomes a river, each bend connected to the last, flowing toward what is yet to come. Imagine holding an old photograph. The picture is static, frozen in time, but when you look at it, memory adds motion. You hear the voices, feel the air, recall the emotions that filled that day. The photograph triggers the reconstruction, allowing you to step backward. It is not a literal journey through time, but in a sense it feels like one. You are transported, if only for a moment, to another now. There is a quiet beauty in this. The past is gone, entropy has carried it away, and yet memory allows you to hold it again. Not perfectly, not permanently, but tenderly. Each recollection is like a shell carried from the sea, smoothed, incomplete, but still resonant with the sound of waves. In remembering, you live again, and in doing so, you shape your sense of time. At the same time, memory is not only backward-facing. The same brain networks that recall the past are used to imagine the future. When you daydream about tomorrow, when you picture what a week or year ahead may hold, you are borrowing the machinery of memory to construct possibilities. The time machine does not only carry you backward, it allows you to step forward, to create scenarios not yet real. This ability, sometimes called mental time travel, is central to being human. It lets you prepare, plan, and hope. It allows you to live not only in the present, but in a larger landscape of possibility. And yet this time machine is fragile. Forgetfulness erases parts of the past, and with them, pieces of the self. Diseases like Alzheimer's do more than take memories. They unravel continuity, loosening the thread that binds past to present. When memory falters, time itself feels altered, as though the river has broken into pools. For those who experience this, and for those who love them, the distortion of time is not abstract. It is painfully real. Still, for most of us, memory remains a companion, flawed but faithful. It may change details, compress or stretch intervals, but it grants us the gift of continuity. It gives meaning to anniversaries, weight to stories, and richness to lives. Without it, every day would be new, but also rootless. With it, you carry a past within you, shaping how you feel the present and how you imagine the future. So as you rest tonight, let your mind wander back. Recall a childhood moment, perhaps a simple one, lying in grass looking at clouds, or listening to a song that seemed endless. Feel how that memory stretches time, how it makes the years soften and blur. This is your time machine, carrying you gently through what was, giving you a glimpse of what might be. Imperfect, yes, but profound. And in the quiet act of remembering, you're not only visiting the past, you're reshaping your present, lengthening it, softening it, letting it breathe. Time, as you feel it, is not only measured by clocks or calendars, it is shaped moment to moment by the state of your mind. Sometimes hours vanish in what feels like minutes. Other times, a single minute drags so heavily it seems to last an eternity. These stretches and compressions are not tricks of physics, but shifts in attention, emotion, and experience. 3 states in particular reveal how elastic time can feel: flow, fear, and boredom. Begin with flow. Psychologist Mihaly Csikszentmihalyi described flow as a state of complete absorption in an activity, when you're so focused that you lose track of yourself and of time. It happens when challenge and skill meet perfectly. Too easy and you become bored, too difficult and you become anxious. But when balance is struck, you slip into a current where effort feels natural and time becomes invisible. Hours pass unnoticed. You emerge from the task surprised at how late it is, how the day has disappeared. Imagine a painter bent over a canvas, brush moving steadily, each stroke building on the last. The world beyond the canvas fades away. Or a musician lost in a piece, fingers gliding across strings, the sound unfolding as though guided by something deeper than thought. Perhaps you have felt it too, writing, coding, gardening, or even in a conversation so rich you forget the passing of hours. In flow, attention is so concentrated that the present expands, yet time itself seems to vanish. It is not that you feel time flying, it is that you no longer notice it at all. Fear shapes time differently. In moments of sudden danger, time seems to slow. People who have been in car accidents often report that the world moved in slow motion. The screech of tyres, the tilt of the vehicle, the sound of shattering glass, all stretched as if the brain were recording every detail frame by frame. In truth, time does not slow. Your heart races, your adrenaline surges, your senses sharpen. The brain, suddenly on high alert, encodes more detail per second, and in memory, the event feels longer. The present is stretched not because the clock falters, but because the mind gathers more than usual into each moment. Picture standing on a ledge looking down. Your breath shortens, your pulse quickens. The seconds before you step back feel heavy, thick, far longer than the ticks of a watch would suggest. Fear sharpens attention to survival, and survival demands detail. Later, when you recall the moment, you find that it lingers in memory more vividly than countless ordinary hours. The weight of fear leaves its imprint on the perception of time. Boredom, on the other hand, stretches time not by sharpening detail, but by hollowing it out. When you wait in a line that barely moves, when you stare at a clock in a classroom, when you sit in a meeting that feels endless, each minute seems to double. Attention, restless and unanchored, notices every tick of the second hand. The present feels sticky, dragging you through molasses. Unlike flow, where you forget yourself, boredom makes you acutely aware of yourself and of time's slowness. Each second is felt twice over, and the hour becomes unbearable. Think of waiting at a bus stop on a rainy day. You glance at your watch, certain 10 minutes have passed, but only 3 have. You shift your weight, sigh, and glance again. The rain drips, cars pass, your impatience grows. In reality, time is steady, but subjectively, the moment swells. Boredom fills the present with too little content, and the mind, desperate for stimulation, stretches the perception of time until it groans. These 3 states, flow, fear, and boredom, reveal that your experience of time is not fixed but flexible, sculpted by the quality of your attention. Flow contracts awareness of time, fear expands it, boredom distorts it. Together they show that time as lived is not the same as time as measured. You live not by seconds and minutes, but by the fullness or emptiness of experience. This elasticity has practical consequences. It explains why childhood feels longer than adulthood. Novelty and intensity fill early years, while routine and familiarity compress later ones. It explains why vacations feel short while they happen, but long in memory, full of rich detail. It explains why a joyful evening passes in a blink, while an anxious wait stretches endlessly. Time as experienced is an emotional, psychological landscape, shifting like clouds, never uniform. There is also a kind of wisdom in this. If you wish to make life feel longer, fill it with novelty, with flow, with moments of awe. If you wish to soften the heaviness of boredom, find ways to anchor attention, even in the smallest details. A bus ride can drag, but noticing the rhythm of raindrops, the colours of passing umbrellas, the hum of the engine can reshape the moment. The present is elastic, and though you cannot control the clock, you can shape how you inhabit it. As you rest tonight, think of the ways you have felt time stretch and shrink. Recall a moment of deep immersion when hours disappeared unnoticed. Recall a moment of fear when seconds expanded like whole worlds. Recall a dull wait when minutes dragged unbearably. All of these are you, experiencing time not as physics dictates, but as your mind interprets. Time is not only out there, written in stars and equations, it is also in here, in the shifting currents of perception, as intimate as breath, as changeable as thought. When you close your eyes at night and drift into sleep, you do not step outside of time, you carry it with you, but in dreams it changes its nature. The steady beat of clocks is replaced by something stranger, more fluid, and often more mysterious. A dream can hold entire stories, conversations, journeys, even years of imagined life, compressed into minutes or seconds. When you wake, you sometimes marvel at how much happened in what must have been so little time. The sleeping clock does not follow the rules of the waking one. During sleep, your brain cycles through stages, from light dozing to deep, slow-wave rest, and then into rapid eye movement, or REM sleep. It is in REM that most vivid dreams occur. Brain activity in this stage resembles wakefulness, with neurons firing rapidly, eyes darting under closed lids, and the mind constructing elaborate narratives. Yet the body is stilled, muscles paralyzed to prevent acting out the dream. In this paradoxical state, intensely active mind within a quiet body, time takes on its dreamlike distortions. Imagine a dream in which you're walking through a city. The streets stretch endlessly, filled with faces and voices. You stop at a cafe, sip a drink, speak with a stranger. Hours seem to pass. Then you wake and find only 10 minutes have gone by. The brain, free from the anchor of external clocks, generates sequences untethered from physical duration. Neural patterns race and leap, creating the illusion of extended time. What feels long may be short, and what feels short may fill an entire night. Some researchers suggest that dreams compress time because the brain is not bound to process every detail of reality. In waking life, perception must account for sensory input, light, sound, touch, all streaming in relentlessly. In dreams, the mind is freer, sketching broad strokes rather than recording fine detail. Like a painter suggesting a landscape with a few gestures, the dream builds the impression of hours with only fragments. The result is a narrative that feels full yet requires little real time to create. There is also the curious fact that dreams often lack clocks. You rarely see a watch in a dream, and when you do, its numbers may shift and blur. The mind does not measure dream time with instruments, it measures with feeling. A conversation feels long because it is emotionally charged, not because minutes have ticked away. A chase feels stretched because fear slows perception, just as it does in waking life. In dreams, the psychological arrows of time, memory, causality, emotion, become the only arrows. Physical time recedes into the background. Think of how dreams also play with sequence. You may recall speaking to a friend, then suddenly standing in another city, then flying through the air. The transitions lack explanation, yet within the dream they feel natural. Time's continuity dissolves, replaced by a patchwork of moments stitched together without cause. And yet the mind accepts it. You do not wake in the middle of a dream to protest that the story makes no sense. You flow with it, as though another kind of time governs, one where logic yields to association. Dreams also blur past and future. A memory from childhood may mingle with an imagined future, both coexisting in the same dream. Entropy, causality, cosmological expansion. None of these arrows constrain the dream. Instead, memory and imagination merge, creating timelines that are both backward and forward. The dream is not a journey through time, but a canvas where times coexist. This dream clock has fascinated philosophers and scientists alike. Augustine once wrote of dreams as reminders that our experience of time is not fixed, that it can fold and stretch in ways the waking mind cannot grasp. Modern neuroscience frames it differently, pointing to REM activity, hippocampal replay, and the way the brain rehearses and reorganizes experiences during sleep. Yet the effect is the same. Time becomes malleable, subjective, strange. There is comfort in this malleability. Dreams allow you to live outside the rigidity of seconds and minutes. They permit you to wander landscapes where hours can pass in an instant, where the past returns and the future arrives early. Dreams remind you that time as experienced is not simply physics but perception, and perception is endlessly creative. And so, as you drift deeper into rest tonight, imagine your own sleeping clock preparing to loosen its hold. Your circadian rhythm has dimmed the lights, melatonin has risen, and now the mind begins its journey inward. Soon, in REM sleep, your eyes will flicker beneath closed lids, and stories will unfold. You may find yourself in a place from long ago, or in a place that has never existed. You may live a lifetime in a handful of minutes, only to wake with the sunrise and wonder at the strangeness of it all. In those dreams, time will not behave as it does here. It will not move forward in strict sequence, nor will it tick steadily. It will be soft, pliable, as if woven from memory and imagination rather than from the universe's laws. And when you wake, you will return to the clocks on your walls, the ticking of seconds, the pull of schedules. But perhaps you will carry with you a reminder that time is not always as rigid as it seems, that within you exists a sleeping clock capable of bending it into shapes both strange and beautiful. Time travel is often imagined as a sudden leap, Step into a machine, press a button and emerge centuries ahead. But the universe offers a quieter, subtler form of time travel, one that is not fantasy but fact. It does not happen with glowing portals or humming engines, but with speed and gravity. It is written into the equations of relativity and has already been tested, not in science fiction, but in laboratories, in satellites, and even in the lives of astronauts. The principle is simple. Time does not pass at the same rate for everyone. Motion and gravity bend it, stretching or compressing the rhythm of seconds. A clock on a fast-moving spacecraft will tick more slowly than a clock on Earth. A watch worn in orbit, far from the pull of Earth's surface, will run faster than one kept on the ground. Both effects are real, measurable, and have been confirmed again and again. Imagine two friends. One stays on Earth, while the other boards a spacecraft and travels near the speed of light. To the traveller, days pass normally. Meals are eaten, conversations shared with crewmates, sleep taken in the quiet hum of a cabin. But when they return to Earth, they find that decades, or even centuries, have passed for those who remained behind. The traveller has leapt into the future. This is the twin paradox brought to life, not by fantasy, but by relativity's quiet logic. We cannot yet send ships to such speeds, but the principle has been confirmed on smaller scales. In 1971, physicists Joseph Haffel and Richard Keating carried 4 atomic clocks aboard commercial airplanes, flying them around the world. When compared with identical clocks kept stationary, the travelling clock showed measurable differences, in perfect agreement with Einstein's predictions. Time had stretched and compressed just as the equations demanded. Satellites provide an everyday demonstration. The global positioning system, which guides drivers and hikers and ships, depends on precise timing. Each satellite carries an atomic clock, and those clocks tick differently than the ones on Earth. Because satellites move quickly, special relativity slows their clocks. Because they orbit farther from Earth's gravity, general relativity speeds them up. The combined effect is that satellite clocks gain about 38 microseconds per day compared to Earth clocks. That seems tiny, but if left uncorrected, GPS would drift by kilometers every day. Your phone could not tell you where you were, planes could not navigate safely, and shipping would descend into chaos. Each time you follow a blue dot on a map, you are leaning on time travel corrected by relativity. Astronauts too live this truth. When cosmonaut Sergei Krikalev returned from 803 days in space, he had aged a fraction of a second less than people on Earth. The difference is minute, but it is real. He had travelled slightly into the future, carried by orbital speed and gravitational effects. Every astronaut aboard the International Space Station circling Earth 16 times a day experiences time differently than those on the ground. They live in the same world, but their clocks whisper a different rhythm. This future travel is subtle, but it shows that time is not fixed. It is flexible, pliant, relative. If technology one day allows near light speed journeys, the effect will be dramatic. A crew might leave Earth, travel for a few years at great speed, and return to find centuries have passed. They will have walked into the future, while those left behind lived and died in their absence. What science fiction imagines as sudden leaps, physics reveals as steady drifts, waiting to be harnessed. There is wonder in realizing that time travel is not fantasy, but a quiet feature of the universe. You do not need a machine, you need only speed or gravity. In principle, you could climb a mountain and live ever so slightly ahead of those in the valley, because your clock ticks faster in weaker gravity. The difference is imperceptible, but it exists. You could say that mountain climbers are time travelers, carried forward by height. It is humbling to recognize that even now, as you sit and listen, your own body is a patchwork of time. Your head, farther from Earth's core, ages faster than your feet. The difference is unimaginably small, fractions of a nanosecond, yet it is real. You're not a single clock, but a collection of rhythms, each tied to gravity and motion, each living a slightly different future. Perhaps this realization softens the strangeness of time travel. It is not a violation of laws, but an extension of them. You're already doing it, inch by inch, second by second, carried by the relativity of motion and gravity. Astronauts do it more dramatically, satellites even more so. The future is not somewhere you leap into suddenly. It is a place you arrive at slowly, differently than others, guided by the pliability of time. So tonight, as you rest, consider that you too are travelling forward, not only in the ordinary sense of time's arrow, but in the relativistic sense as well. Every heartbeat, every breath carries you into the future. You may not notice it, but your seconds are not quite the same as someone else's. And perhaps that is the gentlest truth of relativity. We all walk our own time, stitched together by motion and gravity, yet still share the story of the same universe. If travelling into the future is not only possible but already happening in subtle ways, the question naturally arises: can we travel backward? Could someone step into a machine or a tunnel in space and return to yesterday, or even centuries ago? It is one of humanity's oldest fascinations, and though physics does not forbid it entirely, the answers it offers are both strange and uncertain. To speak of travelling to the past is to walk into a landscape of wormholes, paradoxes and possibilities that blur the line between science and philosophy. The most famous doorway to the past in physics is the wormhole, sometimes called an Einstein-Rosen bridge. In theory, a wormhole is a tunnel connecting 2 points in spacetime, perhaps separated by vast distances, perhaps even by time itself. Imagine space and time as a sheet of paper. If you fold the paper and poke a hole through, 2 distant points touch. Travel through the tunnel, and you emerge elsewhere or elsewhen, bypassing the long road across the surface. It is a compelling vision. Shortcuts through the cosmos, gateways through history. Einstein's equations allow such structures, but allowance is not the same as existence. Wormholes would require exotic matter, substances with negative energy density to remain stable. Without it, they would collapse too quickly for anything to pass through. No one has ever observed exotic matter in the quantities needed. For now, wormholes remain mathematical curiosities, sketches in the margins of relativity's notebooks. Still, their possibility fuels imagination, because they dangle before us the dream of undoing time. But if a wormhole did open, if you could walk into one end and step out yesterday, the puzzles would begin immediately. The most famous is the grandfather paradox. Imagine travelling into the past and preventing your grandparents from meeting. If they never met, you were never born. And if you were never born, how could you have travelled back in the first place? The paradox ties itself in knots, a loop without resolution. Physics, normally so crisp, finds itself caught in contradictions. Some physicists, however, suggest that paradoxes may not exist because the universe simply forbids them. Perhaps the laws of physics conspire to prevent actions that would create contradictions. You might travel back in time, but events would always unfold in a way that preserves consistency. Try to stop your grandparents from meeting, and something intervenes, chance, accident, your own hesitation, ensuring that the past remains unchanged. In this view, time is self-healing, incapable of being broken. Others propose a different escape, the many worlds interpretation. According to this idea, if you travel into the past and change something, you do not alter your own history. Instead, you create or step into a parallel timeline, a branching universe where events diverge. In your original universe, your grandparents still meet, you're still born, and history continues untouched. But in the new branch, a different story unfolds. Paradox dissolves, but at the cost of multiplying realities. Every change becomes a new world, every possibility realized somewhere. It is worth noting that even if wormholes or closed time-like curves could exist, no practical evidence supports them. They remain theoretical, perched on the edges of equations, beyond current technology. The universe may allow them in principle, but nature has not shown us an example. And even if such doorways could be built, the exotic matter needed to hold them open may lie forever beyond reach. Still, the fascination with backward travel persists because it touches something deeply human. Who has not wished to return to a moment, to relive a conversation, to undo a mistake? The dream of time travel is not just about physics, it is about longing. It is about the ache for second chances, for paths not taken, for the possibility of rewriting stories. Wormholes and paradoxes are ways of giving mathematical language to feelings we all know. And yet, there is also comfort in the thought that the past may be untouchable. If it is fixed, if it cannot be undone, then memory becomes precious. The fleetingness of moments gains weight because they cannot be retrieved. A child's first steps, a sunset shared with a friend, the sound of laughter in a particular room, all become more meaningful because they happen once and only once. The impossibility of backward travel is also the gift that makes the present real. So as you lie here tonight, imagine a wormhole unfolding in the dark, a tunnel arcing through space-time. You step inside, the air shimmering around you, and emerge in a street from your childhood. You hear familiar voices, see familiar places, but then you remember. This is only a dream of physics, a thought experiment. The real journey into the past is the one your mind already makes through memory. No wormhole is needed. You carry your own time machine within, fragile but profound. Physics may leave the question open, tantalizing but unresolved. Perhaps wormholes exist. Perhaps paradoxes dissolve in many worlds. Perhaps the universe is simply consistent, forbidding changes that would shatter it. But whether or not backward travel is possible, the yearning for it reminds us that time is not only an equation, it is a human experience, full of hope, regret, and wonder. There is a way of looking at time that challenges almost everything your intuition whispers to you. It is called eternalism, or more commonly, the block universe. In this vision, past, present, and future are not flowing like a river, one moment replacing the last. Instead, they all exist together, spread out in a vast four-dimensional structure of space-time. Each instant, from the first flicker of the Big Bang to the conversations you have not yet had, is already there, fixed in the fabric of the whole. The flow you feel is not time itself moving, it is you, moving through the block. Imagine a library filled with books. Each book tells a complete story, beginning to end, already written. To you reading the story, events unfold one page at a time. The characters live their lives in sequence, each page replacing the last. But to someone holding the entire book, every page exists simultaneously, every sentence already in its place. The block universe suggests that reality itself is like that library. The chapters of your life, the pages of history, even the unwritten volumes of the far future are not waiting to be written. They are already on the shelves. This idea stands in contrast to presentism, the more intuitive belief that only the present is real. According to presentism, the past has slipped away into memory, and the future is yet to be born. The only truth is now, the thin edge on which you live. Eternalism denies this. It insists that the past is still there, the future already there, and that your sense of moving from one to the other is an illusion of perspective, much like seeing a landscape appear in pieces as you walk across it. The mountain existed before you saw it. The valley will exist long after you pass. Philosophers have long wrestled with this. Augustine, writing more than 15 centuries ago, captured the strangeness of time with his famous paradox. What then is time? If no one asks me, I know. If I wish to explain it, I do not. In the block universe, Augustine's uncertainty finds a kind of answer. Time is not flowing, not vanishing, not arriving. It is simply there, all at once, incomprehensible, because you are built to perceive only one slice at a time, Einstein himself, whose relativity made the block universe possible, once wrote in a letter after the death of a friend that the distinction between past, present, and future is only a stubbornly persistent illusion. He meant not that time is meaningless, but that the divisions you cling to may not exist outside perception. The universe does not divide itself into was and will be. It simply is, eternal and complete. There is something unsettling in this, but also something strangely comforting. If the block universe is true, then the moments you have loved are not gone. They are still there, fixed in the structure, as real as the moment you are, in now. The future you fear or anticipate is also there, waiting, though unseen. You may not be able to reach backward or forward, but those instants exist nonetheless, like rooms in a vast mansion you cannot enter all at once. Picture yourself walking through such a mansion. Each room is a moment. You enter one, explore it, and then step into the next. You cannot occupy two at the same time, but both exist side by side. You cannot return to the room behind you, nor see clearly into the one ahead, but their presence is undeniable. Your journey is the experience of passing through, but the mansion itself is timeless, every room already in place. Still, presentism has its defenders, because it feels true in your bones. The past feels gone, the future unreal. Only now seems solid. You can point to this moment, this breath, this word, and say, "This is real." Presentism resonates with how you live, even if eternalism resonates with how physics describes the universe. It may be that both are perspectives on the same reality, the way sunrise can be both the earth turning and the sun rising depending on your view. Whether you lean toward presentism or eternalism, the block universe or the fleeting now, what matters most is how these visions shape the way you feel. Eternalism offers permanence. Nothing is lost. Everything is preserved in the structure of space-time. Presentism offers immediacy. The past is gone, the future uncertain, so the present is precious. Both hold truths you can carry gently. So tonight as you rest, let yourself imagine that the moments of your life are not scattered and gone, but preserved, etched into the fabric of the cosmos. The laughter of childhood, the first time you held someone's hand, the evenings you thought would never end. They are not destroyed, only fixed in their place, and the moments yet to come, walks you will take, words you will speak, are already woven into the whole. You need not see them for them to be real. You need only keep walking room by room, page by page, beat by beat. By now, you have wandered through time as Newton's steady stage, as Einstein's flexible fabric, as entropy's one-way street, and as the block universe's eternal landscape. Each vision offers something profound, yet each leaves the same lingering question. Does time truly exist as part of the universe, or is it something born within us? Some physicists, including Carlo Rovelli, suggest that time may not be fundamental at all. Instead, it may be emergent, arising from relationships and change, from the way matter and energy interact. If that is true, then perhaps time, as you feel it, is less a feature of the cosmos and more a creation of the mind. Think of how memory shapes your sense of the past, how anticipation builds your sense of the future, how attention sculpts your sense of the present. Without these, what would time mean to you? Imagine if you could not remember yesterday, if you could not imagine tomorrow. Would time exist for you in any meaningful way? You would be left only with sensation, an eternal now without before or after. In a sense, you would be living outside of time, even while the universe marched on. Rovelli often describes time as a perspective, not a thing. In his view, what exists are events, changes, interactions. To say that time passes is to say that things happen, one after another. Time is not an independent river carrying events along. It is the story we tell about change itself, Without change, without difference, there would be no time. It would not be flowing. It would not even exist. This resonates with your own experience. Moments blur when nothing happens, when days are filled with sameness. But when change is abundant, new places, new people, new experiences, time feels rich, textured, expanded. It is not the clock that changed. It is the story your mind told. Time is narrative, memory, perception. It is as much psychological as physical. Consider the way cultures have shaped time differently. In some traditions, time is linear, moving from past to future in a single line. In others, time is cyclical, repeating with seasons, rituals, and rebirths. Which view is correct? Perhaps both. Perhaps neither. Perhaps time is not something the universe dictates, but something the human mind interprets, a lens through which to make sense of change. And yet, even if time is only a perception, it remains the most profound perception we have. It gives structure to your life. It grants meaning to beginnings and endings, to stories told and lives lived. If it is an illusion as necessary as breath. The illusion binds memory to identity, hope to action, and dreams to tomorrow. Without it, you could not say who you are, nor imagine who you might become. There is a gentle humility in this idea. Time may not be carved into the foundations of the cosmos, but it is carved into you. It is the way you perceive, the way you remember, the way you imagine. To live as a human is to live in time, whether or not the universe does. Perhaps this is why, even if time is emergent or illusory, it feels so real. You cannot escape its flow, not because it flows outside you, but because it flows within you. Memory, attention, perception, they create the river you experience. The arrow you feel is the arrow of your own mind, stitching change into story. So tonight, as you rest, let this thought settle softly. Time may be less a feature of the cosmos and more a feature of you. Even if physics one day shows that the universe is timeless, you will still carry the sensation of time, because you are a creature of memory, of imagination, of narrative. And that sensation is no less real for being subjective. Whether time is fundamental or emergent, real or illusory, it remains the stage of your life, the rhythm of your breath, the pulse of your story. You cannot step outside it, but you can learn to dwell gently within it, to notice its textures, to savor its flow. And if, in the quiet of night, you find yourself wondering whether time is real or imagined, you need not be troubled. For real or not, it has given you childhood summers, conversations at dusk, laughter that lingers, and dreams that unfold in darkness. Illusion or reality, it has given you a life, and that is enough. After all the ideas, all the physics and philosophies, you might expect a firm conclusion, a single answer to what time really is. But time resists that kind of closure. It is too vast, too subtle, too deeply woven into the fabric of your life. Instead of conclusions, what remains is a feeling, a sense, a quiet presence. Tonight, rather than summarizing, let us listen to the lull of clocks, to the rhythms that whisper to us, to the patterns that remind us of time without demanding we solve it. Think of a clock on the wall, its hands moving with patient steadiness. Each tick is small, barely audible, but together they form a rhythm that feels like a heartbeat for the room. You might not notice it during the day, when voices and footsteps fill the air, but at night the ticking becomes clearer, almost comforting. The clock does not rush, does not linger, it simply carries on, marking change with gentle insistence. In its sound, you hear not just seconds, but the presence of time itself, steady and calm. Now shift your attention inward, to your own heartbeat. It is quieter than any clock, but you can feel it if you place a hand over your chest or rest in silence long enough. It is the first rhythm you ever knew, beginning before you were born and continuing without pause. Each beat is like a drum in the background of your life, a reminder that you are carried forward, not in leaps, but in pulses. You do not command it, it simply happens, a gift of continuity. Add to that your breath, rising and falling like the tide. Inhale, exhale, the cycle repeats, marking time in waves rather than ticks. The rhythm of breath is softer than that of heart, but it too is unceasing. Together, heartbeat and breath form the lullaby of your body. Even as the mind races, even as thoughts wander, they keep steady time, whispering that the present is enough. These rhythms are echoed in the world around you. Waves lap against shores with unhurried patience. Candles burn, their wax shrinking slowly as flames flicker. Trees shed leaves in autumn, bud in spring, repeating cycles as old as the earth itself. Stars wheel across the sky each night, the same constellations appearing and disappearing, reminding you that even on cosmic scales rhythms endure. The universe hums with clocks of every kind, from the smallest vibration of atoms to the slow dance of galaxies. When you think of time in this way, not as a problem to solve, but as a gentle presence, it becomes less something to fear and more something to rest inside. The ticking of a clock, the pulse of a heart, the rhythm of waves, each is a reminder that time is not only fleeting, not only vanishing, it is also sustaining, a background that holds you. Without it, there would be no story, no change, no growth. With it, there is a song that unfolds quietly, patiently. And though physics debates whether time is absolute or relative, whether it is fundamental or emergent, your experience of time is immediate. You feel it in the cooling of tea, in the soft fade of a day into night, in the stillness of waiting, in the rush of joy. These are not equations but sensations, and they are no less real for being subjective. They are your way of listening to the lull of clocks, even when no device is nearby. Perhaps this is why bedtime itself carries such resonance. As you prepare to sleep, you become aware of time in its gentlest form. The day is behind you, the future not yet here, and you rest in the liminal space of the present. The clock on the wall still ticks, your heart still beats, your breath still flows, but you do not need to measure them. You can let them blur into background music, steadying you as you drift. If you listen closely, you may even hear how time soothes. The sound of rain tapping on a window, the repetition of waves, the creak of a floor settling, all are reminders of change, but softened, stretched, transformed into rhythms that comfort rather than demand. Time is not rushing past you. It is holding you, wrapping you in continuity, inviting you to let go. So tonight, instead of trying to grasp what time is, perhaps it is enough to feel its lull, to notice the candle's flicker, the wave's repetition, the whisper of a clock, the pulse of your own heart. These are the voices of time, not stern or commanding, but gentle, patient, willing to sit beside you as you drift towards sleep. Time is not only a mystery to be solved, it is a lullaby to be heard, a quiet presence to be felt, a companion on the journey of every day. You have wandered with me through so many landscapes of time tonight, through clocks and stars, through memories and dreams, through physics and philosophy. And yet, after all the wandering, what lingers is not the need for answers, but the presence of the journey itself. Time, whatever it may be in equations or theories, has been your companion for every breath, every heartbeat, every thought. You're not outside of its story, watching it unfold from a distance. You are part of it, written into the script with every moment you live. Think of how each day is a chapter, each hour a line, each heartbeat a word. You may not see the whole book, but you are inside it, carried forward as the story unfolds. Sometimes the pages turn quickly, sometimes slowly, but they are always turning. You are the reader and the character at once, and time is the invisible narrator guiding the tale. It can be tempting to think of time as an enemy, slipping away, stealing youth, erasing moments. But perhaps it is gentler than that. Perhaps time is not a thief but a companion, walking beside you, reminding you that life is made precious precisely because it moves. Without time, there would be no change, no growth, no story at all. A frozen world might be eternal, but it would be silent, empty, without laughter or memory. It is time's flow that gives you the gift of beginnings and endings, of journeys and arrivals. Picture yourself standing at the edge of a river at dusk. The water flows steadily, carrying reflections of the sky. You cannot stop it, nor can you hold it in your hands, but you can watch it, listen to it, feel its coolness if you reach down. Life is much the same. You cannot stop its current, but you can dwell within it, noticing its beauty, letting it carry you gently forward. The river is not your enemy, it is your way home. And as you rest tonight, remember that you are not alone in this. Every person you know, every creature on earth, every star in the sky is moving through time alongside you. Some travel quickly, some slowly, but all share the same journey. When you feel isolated, you can remember that across the world, others are also listening to clocks tick, to hearts beat, to days fade into night. Time is the thread that binds us, weaving billions of lives into a single tapestry. Even your dreams are part of the story. When you drift into sleep, your mind does not abandon time. It reshapes it, bending it into new forms. In dreams, you may wander through childhood, leap into futures not yet lived, or inhabit moments that never happened. These too are stories, softer ones, stitched by the same thread of memory and imagination. You are a storyteller even as you sleep, your mind weaving time into tales that soothe and bewilder, entertain and reveal. Perhaps that is the quiet truth of all this exploration. Time is not only what physicists measure or philosophers debate, it is what you live, what you feel, what you shape into stories. Time is not a clock outside of you, but a rhythm inside you. It is not an abstract stage, but the pulse of your days. Whether it is fundamental or emergent, eternal or illusory, it is the medium in which your life is written. So sleep now, little storyteller. Let the clocks tick without you for a while. Let the river flow unseen. You do not need to measure it tonight. Your heartbeat will keep its rhythm. Your breath will keep its tide. The stars will wheel silently above. Time will hold you while you rest, carrying you gently forward until morning, and when you wake, you will step into another page, another chapter, another stretch of story. The past will remain behind, the future still ahead, but the present will open before you like a fresh path. Wherever you go, whenever you arrive, time will be with you, not as an enemy, but as a quiet companion, steady and patient, walking beside you all the way. So close your eyes now and let the story soften. The clocks, the heartbeats, the waves, the memories, all will keep whispering, all will keep flowing. Time will be here when you wake. For now, let it be your lullaby. Sleep peacefully wherever and whenever you may be.